A functional Typesense instance is essential before integration. This could be a local setup, a cloud service like Typesense Cloud, AWS, GCP, or Azure, or a self-managed deployment. The Typesense instance can be local, in the cloud on platforms such as Typesense Cloud, Amazon Web Services, Google Cloud Platform, Microsoft Azure, or through self-managed deployment, each offering different advantages. The API key is crucial for securing access. LangChain application needs this key to authenticate with Typesense and perform actions, so keep it safe. Configuring connection parameters requires specifying the Typesense instance's host address, either an IP address or domain name, along with the correct port number and protocol, such as HTTP or HTTPS. Defining a schema involves specifying the fields, data types, and designating a field for vector embeddings, crucial for similarity searches in Typesense. The float, data type stores vector embeddings, and maintaining consistent dimensionality, or length, across all embeddings is critical for accurate vector searches. Indexing prepares fields for efficient searching, and for vector search, specify the vector field along with related parameters to optimize search performance. The initial step involves preparing the Typesense environment and configuring the necessary credentials to enable secure communication between LangChain and Typesense. Action highlights the necessity of having Typesense actively running, either locally, on a cloud platform, or through a self-managed setup. For development purposes, a local installation allows for rapid prototyping and experimentation, without external dependencies. Cloud-hosted solutions such as Typesense Cloud, AWS, GCP, or Azure offer scalability and managed infrastructure for production environments. A self-managed deployment provides maximum control over the Typesense instance, allowing for customized configurations and security settings. Action stresses the importance of acquiring an API key, which is essential for authenticating LangChain applications with the Typesense instance. The API key serves as a credential, validating the LangChain application's identity and granting it permission to access Typesense resources. Proper configuration of the Typesense instance involves specifying the host address, port number, and communication protocol to establish a connection. The following Python example demonstrates how to set up the necessary parameters to connect to Typesense. It loads the API key from an environment variable, ensuring it's kept separate from the code for security. Example script demonstrates setting the host to localhost, the port to 8108, and the protocol to HTTP. Secure storage of the API key is crucial, and should be handled with utmost care to prevent unauthorized access. An API key can be loaded from environment variables, like Typesense_API_key, enhancing security. This involves obtaining access to a Typesense server. Think of it as getting the keys to your database kingdom. It includes authentication credentials. This refers to having a Typesense server actively running and accessible. It's like ensuring your shop is open for business. This is a prerequisite for connecting LangChain. This option involves installing Typesense directly on your computer. It's ideal for development and testing as it keeps everything contained. Cloud hosting means using a service provider to run your Typesense instance. It offers scalability and ease of management but usually comes with a cost. AWS stands for Amazon Web Services, GCP means Google Cloud Platform, and Azure denotes Microsoft Azure. This involves setting up and maintaining your Typesense instance on your own infrastructure. This grants complete control but requires technical expertise and effort. An API key is required to authenticate your LangChain application with Typesense. It's like a password that grants access to the database. API keys should be treated like passwords and stored securely to prevent unauthorized access. Avoid hard-coding them directly into your application code. Environment variables are a safe approach. Configuration involves setting the parameters needed to connect to your Typesense instance. Think of it as providing the address and credentials to access the database. The host address is the IP address or domain name where your Typesense instance is located. It's like the street address of your database server. The port number is the specific port on the host address that Typesense is listening on. It's like the specific door number you need to knock on. This specifies the communication protocol used to connect to Typesense. HTTP stands for Hypertext Transfer Protocol, and HTTPS stands for Hypertext Transfer Protocol Secure. HTTPS provides encrypted communication for enhanced security. Environment variables offer a secure way to store sensitive information like API keys. This helps to prevent them from being exposed in your code. The process of verifying the identity of the application connecting to Typesense, ensuring that only authorized apps can access the data. Alright, let's break down how to get your Typesense instance up and running, and how to snag that all-important API key. So, the very first thing is getting your Typesense instance ready. Think of it as setting up your own little Typesense server. Securing an API key is vital for authentication and access control. This is what allows your LangChain application to talk to your Typesense instance. Firstly, it's like getting a password, so make sure this key is obtained from your Typesense setup. It's crucial to store the API key securely, and environment variables are the recommended way to do this. Think of it as keeping your password in a super safe place. Configuring the connection parameters involves setting up the host address, port number, and protocol to ensure seamless communication with the Typesense instance. Now, let's define the schema in Typesense. It's like setting up the structure. For your data, telling Typesense what kind of information it will be storing. The name of the collection, for example, my_documents, is how you'll refer to this set of data in Typesense. Field definitions specify the data types for the information you will store, such as text as string, embeddings as float array, and other metadata as a string. So, here we're dealing with a field type designated for textual data. This is where you'll store the actual text content of your documents. This field will hold vector embeddings, represented as an array of floating point numbers. It's specifically for storing numerical representations of text or images. This is a string field designed to store additional information that's related to each document, such as the source URL. Now, let's dive into indexing. It's like creating an index in a book, making it faster to find what you're looking for. Enabling indexing on the vector field allows to perform efficient similarity searches by optimizing the retrieval of vector embeddings. HNSW, or Hierarchical Navigable Small World, is a commonly used indexing algorithm for vector search, known for its performance. Alright, let's create a Typesense vector store and store document embeddings using the Typesense client object. The Typesense client object serves as the primary interface for interacting with the Typesense instance, managing connections and executing actions within Typesense. Configuring connection details involves setting up the host, port, protocol, and API key to enable seamless communication with the Typesense instance. So, here you're creating the LangChain vector store and connecting it with the Typesense client to allow you to interface with it, using that client. Here the Typesense vector store is initialized with the client, collection name, and embedding function to enable efficient vector storage and similarity search functionalities. Once initialized, document embedding and storage can be seamlessly performed, adding vector embeddings to the Typesense vector store. Now, convert your text documents into vector embeddings using an embedding model, then add them to the Typesense vector store. The client object acts as the interface. It allows interaction with the Typesense instance. This object handles the underlying communication, such as sending requests and receiving responses. Think of it like a key to your Typesense kingdom. A vector store is a specialized database. It stores and retrieves vector embeddings efficiently. The primary function is to perform similarity searches. That's it. Running Typesense instance is like a server. It stores the data and handles search queries. This can be a local setup, a cloud-hosted service, or a self-managed deployment. Ensure it's accessible. A schema defines the structure of data. It specifies the fields, data types, and indexing. A schema in Typesense is crucial before storing any data. Consider it the blueprint for your data organization. API parameters are the credentials. These parameters enable secure communication with the Typesense instance. API key, host, port, and protocol are part of it. Handle them with care. Establishing a connection is the initial step. It requires the host, port, and protocol to link with the Typesense server. It's like plugging in your device. Before loading data, it's essential to define the schema. It specifies the fields, data types, and indexing configurations. This is like declaring the column types in your database table. Passing the client information is like providing login credentials. The client object is instantiated with connection details. The credentials ensure secure and authorized access. Creating an instance involves instantiating a Typesense object. It integrates with your LangChain setup. This combines the search capabilities with your application. Configuration involves setting up the client. It's completed with the host, port, protocol, and API key. Accurate setup is crucial for seamless connection. Now, let's create your Typesense vector store within LangChain. This setup will link your data to your search engine. Now, this step initializes Typesense vector store. It's done using LangChain. This integrates the search functionalities within your application workflow. Now, let's discuss configuring the connection parameters. It involves setting the host address, which could be the IP address or domain name, the port number, and the protocol, either HTTP or HTTPS if transport layer security or secure sockets layer is being used. These parameters are crucial for LangChain to communicate with the Typesense instance. Okay, a Typesense instance refers to a running deployment of the Typesense search engine. This could be a local setup, a cloud-hosted service like Typesense Cloud, or a self-managed deployment on platforms like AWS, GCP, or Azure. Let's talk about the API key. It is a secret key used to authenticate the LangChain application with the Typesense instance. Think of it as a password that grants access and specifies what permissions the application has, such as read or write access.